Very good morning, everybody, and welcome to the Drake Forum at Hamvention 2013. The theme of Hamvention this year is DX. And as we all know, DX stands for distance, or going the extra mile. And who else other than our active duty military do go the extra mile? Let's give a round of applause for our military. If it weren't for them, we certainly wouldn't be here today. I want to thank the team that was responsible for this forum. We've got Mark, our IT guru. We've got Mark, NAPEP, and Aaron, NAQID. They're the videographers and going to be doing the recording and the editing. So if you want a permanent reminder of the forum, it'll be available online after the forum. And I want to thank the Hamvention staff also for providing the facilities here and doing the excellent job that they do. And if anybody sees a volunteer out in the flea market or in and around the commercial exhibits, do take a minute to say thanks to them, because it's a labor of love. They don't get paid, and they do it willingly year after year. And let's just take a pause to remember the silent keys and those that are not with us today from the military. Okay, today we've got quite a few prizes. We're going to go through the prizes here briefly for the donors. And we have, I don't know, we could even have up to $500, $800 worth of prizes here. Here is a prize donation from Mark. He donated several $100s worth of Drake knobs, knob inlays, and so on and so forth. If you go to his website, you'll see he's got a lot of parts to support the Drake community, and that's at nationwide radio sales. Don Keith, he's the author of Riding the Shore Waves. I don't know if Don is here this morning. I think he's signing books out at the ARRL booth. And I've read the book several times. I've got an autographed copy. It's very uplifting, it's encouraging, it's humorous, it's informative, all of the above. And if you get a copy of that, I'm sure you're going to enjoy reading it, and more than once. The Drake Forum Committee has donated a number of prizes of various types. Donnie Garrett has made some donations also, and he has some relatively unique items for the Drake enthusiast if you're doing repairs, refurbishing, and so forth. There's a lot of custom parts that are no longer available, say, from Drake, since they're not in business, but Donnie's been able to remanufacture, if you will, a lot of these parts that are of interest, and he made several donations. Mike Bryce, he's from the Heath Kit shop, and he donated an AC4 rebuild kit. And for those of you that aren't aware, the biggest issue with the AC4 power supply is the bias. And if the diode opens up, the capacitor shorts are open, whatever, you lose bias. And as some of us know, it'll take out a set of finals in a hurry. And the transmitter doesn't even have to be transmitted. It just has to be turned on, and you can take out a set of finals, and it's just not a happy experience. Rebuilding the supplies is a good idea. Mike March, who's at the back of the forum here. Mike, you want to raise your hand there? Mike donated some end caps for the Drake 7 line, and these are made of more durable plastic and so forth. They're not going to split as easily and so forth as the original Drake designs. And Mike does a fine job of some custom key designs there also, so you might want to visit Mike out in the flea market. Ron, WB4HFN, donated the major prize today. Ron, where are you located? WB4HFN? Ah, there he is. Ron donated a dual band HT, and that's going to be the last prize that we are going to draw today. Gary, K4OAH, donated several CDs. These are the service CDs. Now, they contain information that's in the service manuals or the owner's manuals for Drake, but there's a lot of other valuable information showing about the variants, if you will, within a production line and so forth, and some of the pictures of the parts and so forth. They're invaluable for doing any service work on the Drake lines. Paul, K0UYA, came up with a rebuild kit for the AC4 power supply 2. This one is slightly different from the one that I showed previously, in that this is the two-board design that you install rather than the single board on one side. And now we'll go into the presentations part of the forum. And the first thing I would like to talk about is the MS4 speaker. It's a great speaker. I've got probably 7 or 8 of those, and I just enjoy using them with my Drake Collins, TS590S, and so forth. Can you really improve it, though? Yeah. There's a possibility of using acoustical foam to improve the characteristics of the speaker, if you will. There's a possibility it could improve the bass, reduce a little bit of the hiss and the high frequency noise and so forth, and maybe even reduce some of the harshness from the inside of the cabinet or the walls. And I was just wondering, should I put this foam on the sides, the top, bottom, back, or what? And so I just thought that perfect was the enemy of good enough. So what I did is I bought some acoustical foam. It's available from a large number of online sources as well as stereo and hi-fi shops where they encourage building of speaker enclosures. And I got the kind that had the deepest cones possible. And I just cut it to the outline of the speaker and I inserted it. And it's worked out really great. Now, as far as the MN2700 tuner, I'm a big favor of open wire feed line, ladder line, and transmitting twin lead 300 ohm. And to foster safety, if you will, I made a set of waterproof or weather-resistant connections on the outside so that as storms approach, I can disconnect the ladder line quite rapidly from the house and I don't have to worry about storm damage. But the question is, and incidentally, with this particular approach, the connectors here are nickel-plated. If you get some of the lesser quality ones, they will start oxidizing very rapidly and build up a high resistance joint. So look for the nickel-plated or gold-plated plugs and sockets. Question is, what do you do indoors? Obviously, you don't need the weatherproofing and so forth, but I like a way that I can continue to connect to the MN2700 and other tuners and so forth, so that I can switch tuners, so that I can put an RF ammeter in the circuit and just do a lot of experimenting. And so the question is, how do I make those switches very quickly? Because I didn't want to wait until the next day or even a few hours where propagation might change. So what I did is I fabricated some adapters, if you will. And here again, we've got some, these are actually gold-plated banana jacks. And this is one of those twin mounts, if you will, for the banana jacks that you can get off the internet. This brand happens to be known. And then I've got some offset brackets that are used for mounting PC boards to chassis and cabinets and so forth. And what I did is I installed that on the back of the MN2700 tuner, and you can see how crowded it is with all the coax cables and so forth. But yet with this particular approach, you can rapidly connect and disconnect the transmitting twin lead and so on and so forth from the MN2700 tuner. And like I say, I do a lot of experimenting. I use RF ammeters and I do switch tuners and so forth, and it's made it very easy to do that. As far as the TR5, TR7, TR7A, there's sometimes panel wear by the microphone connector, and a lot of people say, well, I've got one of these rigs and it doesn't look like it's worn to me. So the question is just a matter of waiting. After you use the rig a while, if you change microphones and adapters and so on and so forth, what will happen is that you actually start wearing out the panel. Every time you rotate that shell, if you will, on the connector, one way for putting it on, the other way for removing it, it actually wears the panel. And you'll see over time, it'll actually start dulling and marring the finish and so forth. So this is the standard type of microphone connector. Sometimes there's a right angle one that gets the cable away from the cable. But there's another solution, and that's the Heil microphone connectors. And I do not own stock in the company, gentlemen, but that particular connector has a shell that's 2 to 3 times longer than the standard connector. So when you screw that connector on or you unscrew the connector, you don't touch the panel with your fingers at all, so that avoids that wearing of the panel. And once the panel starts wearing, there's virtually nothing you can do to bring it back. At least I've not found anything that works. The problem with the TR7 and TR7A and TR5, possibly other rigs and so forth, is when you're using an amplifier. And when you tune up, if you're out of resonance with the amplifier, you start developing high RF voltages, particularly in the plate tuning capacitor, and you start hearing that spitting, that arcing, and so forth. And the problem with that is once it stops, it doesn't get better in the sense that you start building up a pit on one side or a crater, and then it starts building up carbon and other things on the other side, so it actually reduces the spacing. So you really don't want that situation to continue very long. Also, when the amplifier is out of resonance, you create a tremendous amount of heat in the tubes. And as we all know, the 3500s are fairly expensive these days, so anything you can do to prolong their life is probably a good idea. Another issue, too, is with regard to the output from the TR7 itself. At a given carrier setting, for example, on the panel, you'll get substantially different values of RF output, sometimes a factor of 2 to 1 when you go from one band to the other. So if you have it tuned up for a low RF output band, let's say, you switch bands and then you just leave it as is, you're driving the amplifier with twice the power, so that can lead to a lot of problems, overdrive and so forth. You can also tune up the amp in CW and then switch to sideband and use other techniques and so forth. The solution, there are several. First of all, some people short the key jack and they just leave a shorted phone plug into the key jack there. And so every time you take the mode switch and put it into CW, you've got a constant carrier. Another approach is to leave it in CW and use a keyer to send dots or use a bug to send a series of dots, which is a low duty cycle and so forth, and that'll help to save the amplifier problem. Ron WB4HFN has an interesting article on his website, and what he's done is that little store switch next to the digital display that nobody seems to use, it now has a purpose. You can use that for keying the transmitter to get it into CW mode for tune-up. Or you can use that unused phone patch to accomplish something. And how does that work? Phone patches aren't usually associated with linears. Well, what I did is there's a device. It's called a 3898 Pecker. It's a audio tuning pulsar, and it gets its name from the sound that it emits. It sounds like the Russian woodpecker that was on the HF bands a number of years ago. And that's that little circuit board there. And this is a dismembered, if you will, phone patch, an iViking phone patch. I have several of those, and it matches the Drake line. And basically, to use something like that, you just assemble that audio pulsar. It just takes about 10 minutes to do that. Take the internals out of whatever phone patch you happen to have, install the audio tuning pulsar, install a potentiometer to set the output level. That tuning pulsar has probably 10 to 100 times more output than what the rig wants to see as an input. So I put a little potentiometer there to cut it down. And then I have a spring-loaded push-to-talk switch that I use for controlling the power. That way you can switch the circuit in, but you don't have to worry about it being on, draining the battery, and so forth. And then you have to fabricate the appropriate connectors and cables. Here's a picture of the assembled unit. This cable goes into the TR7 transmitter. This is the microphone connector. This switch switches the circuit in and out. It switches from microphone input or the tuning pulsar input. And the reason that that's necessary is you don't want to have that high output from the tuning pulsar to go across the microphone element, which might be crystal or ceramic, and it doesn't like to see those voltages. That's the output adjustment there. And that's the spring-loaded switch there that allows you to pulse it or put the signal out for tune-up purposes. And that's the completed unit. It's very convenient. It's small. The color matches the Drake line, and it works very well. If you've got an unused phone patch, or if you see one for $5 out in the flea market, you can consider using something like that. As far as those of us that do collect a lot of Drake equipment, it seems like we're always acquiring equipment. It always grows, and it never diminishes, it seems. And it's always a work in progress, at least my station is, and I move equipment in and out quite frequently. The problem with that is that the table that it's on is quite heavy, and as a result, it's hard to move those tables, and you need 2 men and a boy to move something like that. And the other thing, too, is that with the power supplies, like for the L7, L4B, L4 power supplies, and so forth, they're large, they're heavy. If you put those on the operating table, same way for the PS7 supply, it's taking up valuable equipment space. So what I do is I built a heavy-duty shelf for mounting the power supplies, for the linear and the 7 line. I painted it black to match the Drake line, and I put it under the table but off the floor so that it gets a good ventilation. And then I use a product called furniture sliders, and I'll show you a picture in a moment. These are available from Home Depot, Lowe's, and so forth. And they're designed to move furniture easily, and you can see some on the corners here and here. This is the power supply for the L4B amplifier. That's the PS7 mounted vertically. I had to put some rubber feet under there to get it to mount vertically. And this is a piece of a 2x8 lumber, and you can see it's fairly beefy, and it doesn't bend at all under the weight. And this is what I do to adapt those furniture sliders for my particular application. The table that I have has very narrow feet here. And what happens is when you use these furniture sliders, it actually creates a dimple in there, and it actually adds a lot of friction and makes it difficult to move the table. You can still move it easier than without them, but it's still very difficult because of that dimple. So what I did is I just took some plates from some conduit boxes, I spray painted them black, and I used that to spread the load over the entire furniture slider, if you will. And I can single-handedly move a table that's probably got 250 pounds, if not more, of equipment on it, and I can move it quite easily away from the wall to change cables, do fault isolating, and so forth, and then move it back. It's really a pleasure to make those changes. Another issue with regard to having multiple transmitters, antenna tuners, and so forth with a single amplifier is how to make the selection amongst all of those. It seems like there's always a confusion amongst cables, and you don't want the output of the amp going into your spare rig and so on and so forth. You don't want to. You also want a convenient way of selecting the input to the amplifier. You want the respective rig to be driving the amplifier as you intend. Selection of microphones can be an issue also, and then you want to switch push-to-talk lines for the linear amongst the various rigs. And we all know that Alpha Delta makes some really neat coax switches, and this is what I use to select the appropriate antenna tuner and antenna. It's just a two-position switch. I've got two antennas, a 40-meter horizontal loop and an 80-meter horizontal loop, and antenna tuners. And I just bolted that switch to this board with rubber feet underneath, and I used that to make the switch. Now, Alpha Delta does make a desk console version of their switches, and it's elevated and so forth on an angle, but that's like another $60 over and above the regular switch. And being the cheapskate that I am, I figured I'd save a few bucks.
Question on the switches?
Yes, sir.
Real quick. What's your take on how good the isolation is between the ports? Because I've always worried with two transceivers, one running, and I know on a 2-meter rig with just two antennas, I can hear a repeater with the thing thrown to ground.
Yeah, that's certainly an issue, and I don't recall whether there's 40, 50 dB isolation on these things, but what it does is it does short the antennas to ground for the unused antennas, so you do get a lot of attenuation, but still, I turn the rigs off that I'm not using just as a preventative measure, because the FET front-ends and so forth are very sensitive. So it's even if you have a shorted antenna, you still want to make sure the rig is off just to prevent feedback. I think that's good practice. What I was given is a dirty little secret by Mark, WB0IQK, and he tipped me off about these switch boxes. And these are available at Home Depot, they're available online in a lot of hi-fi outlets and so forth. And these are switches that allow you to select a variety of devices, if you will. And you can get these with USB ports, mic connectors, all sorts of specialized connectors. The one that I picked has RCA phono connectors. And you can use this for switching, like the microphones amongst rigs. You can also use it for switching the push-to-talk line, for example. You don't want to have more than one line connected to the linear at the same time, and so I've got plenty of room for growth there, and it's worked out quite well for me. The next presentation is going to be from Ron, WB4HF, and he's going to be talking about some troubleshooting techniques and so forth for the Drake line. And I'm sure it's going to evoke some questions and issues you care to discuss. And we'd like you to hold off for the question and answers until the very end to make sure we have enough time for everybody to make their presentations. And I'm going to be the fault guy for Ron in terms of timing. But go right ahead, for Ron.
Well, we'll say good morning to everybody.
Morning.
Evan told me I have 10 minutes, and he said he was going to hold up 3 fingers when I have 3 minutes, and he was going to hold up 2 fingers when I had 2 minutes. So, Evan, when you hold up 1 finger, I hope you're telling me I got 1 minute left. Let's see. Okay, today I'm just going to talk briefly for 10 minutes or so about the hints and kinks. As you know, I'm kind of doing some brake repair, and I get a lot of common problems, and a lot of common problems that are easily fixed by you, which will save you the shipping cost and the cost of repairing just by knowing. So, there.
That's a good start.
Okay, the first one I'm going to talk about is the Drake, the R4, R4A, R4B. Remember, it's got the little VFO crystal switch on the side that basically eliminates the VFO for fixed frequency operation. That switch goes bad easily. It gets dirty. So if you're, as it says, if the radio has got good background noise, the calibrator doesn't work, but all the functions seem to be working fine. It just doesn't receive on any band. it's probably that switch. The switch is either in the wrong position, it's either dirty, and a lot of times when you turn the radio on its side and that switch is down, the weight of the radio can push that little switch, push it inward, and it'll push the back of the switch off, and technically it's got a little loose and the contacts are not making contact anymore, and the switch is bad. So you might want to just double check to make sure that it's making contact, because a lot of these switches go bad easily, and I've replaced a lot of switches just because somebody's laid it on its side or it was dirty. Okay, this is very similar. This also applies to the TR4, TR4C, and the whole TR4 and the TR4, TR4C series. The little transceiver switch. I've gotten a couple of repairs that it didn't receive because they had it in the receive position. That is for an external receiver. Always make sure that that particular switch is in the transceiver position. All the same issues apply to this as it applies to the R4 series receiver, especially if you lay it on its side and you push it in, you mash the contacts and you push the little fiber contact board out the back. It goes bad easily. Okay. Now the way you can test it here is if you can still hear the calibrator and it's still got a pretty strong signal. Probably the next thing I would do is check that switch. If that isn't the problem, it's the inside, right? This is the power cable connector right here with the relay. This little what we call a T12 bulb. This is what it looks like. It's a fuse bulb. It can go bad. It can blow, especially if you've got a lot of standing wave or your relay is not clicking fast enough. That bulb will blow. And that will also kill your receiver, and it's mounted right here. This is the little light, the full, the dim switch for the lamps, and it's just right there. Also check to make sure that the pins are crimped together, because sometimes they'll get loose and you're going to get an intermittent condition. If you can wiggle that bulb and your signal comes and goes, the problem is right there. Also on the pin, on the bulb itself, if they're kind of brownish or blackish or where they've tarnished, take a brush, some type of a wire brush, and shine them up. I have been able to get an extra half of a microvolt difference in signal just by cleaning those pins. So if you think your receiver is down a little bit, take a look at that bulb, shine up those pins, because you could make. I've seen it a few times where it actually makes a difference. They discontinued the T12 bulbs about a year ago, and I've seen these T12 bulbs being sold at some of the bulb companies for up to $20 each. I also found out that 1000bulbs.com have them in stock, and they're $2 a piece. So remember that, 1000bulbs.com. Good place to buy bulbs from. There's no minimum. And you can get them for $2 a piece. And I talked to them the other day, and they had about 200 in stock. So if they get inundated with calls, they're going to blame me.
Question. Is that 1,000 or 1,000 milliwatt?
What's that? Yeah, it's 1000bulbs.com.
Thank you.
Okay, the TR7. If your TR7 sounds like it's off frequency, or you can't quite get it tuned in, the BFO oscillators could be off frequency a little bit, which is this adjustment, these adjustments here on the power supply board. They can get bumped easily. So make sure that those are adjusted properly. You've got one for each mode for an adjustment. Before you do any adjustments, this is the 10 volt regulated. Make absolutely positively sure you have 10 volts regulated. It's not higher or lower, 10 volts even. That's the most important, because all of the other voltages to adjust the BFO is drawn from that 10 volt regulated, and you can, any one of those resistors right along the top there, you can put your digital voltmeter over there and set your 10 volts at any one of those. But you need to make sure it's exact. Okay. To set each one of these controls, what I recommend as a quick way of doing it is on 20 meters, drop it down to a tunes 13.5 to 14. If you put it in the AM mode, for instance, you dial 13695 and you will see a carrier. You adjust this control for maximum S meter reading. You go into put it in the RTTY mode, tune for 13697.5 and use 0 beat. If you have an AM filter or you have the AM mod, which is 150 ohm resistor, do it in the AM mode because you can see both sides of the sideband, whereas if you do it in using the sideband filter itself, you can see one side of the filter, but as you go across to the other side, of course, it dies. So do all of these if you've got the AM filter or that AM mod in there. Then again, for CW mode, it's 13694.2, and you just 0 beat, and you go on and so forth and follow those down. This was a little trick that Bill Frost wrote in one of his little articles a year ago, and this is a whole lot quicker and easier than trying to set it with the BFO frequency as it goes. There's an elaborate alignment procedure in the book, but this is just as accurate, and you can set all 5 modes in probably 30 seconds this way. Okay, next. All right, the TR7. It's the worst problem is loose boards. Boards have a tendency to work the way loose when you ship it, when you move it around. They have a tendency to wiggle out of the motherboard socket just by heat over years of use. Anything that's frequency related, this is the digital board right here. There are several. This board can come loose. You push it down. Just push it down, and there are connectors here. There's 3-pin connectors here, and then there's a big connector up here. Push them down, and a lot of times that will fix any frequency display problems. Next, under that board, there are a lot of other boards that are under that digital display board, all having to do with frequency control. So if you have frequency control issues, or it's jumping frequency, or it's not working right, a lot of these boards under that board can come loose, but what you have to do is lift out that digital display board. But basically, all of the boards, and I've got them all labeled here, can vary on the problem. I highly recommend that if you take it apart, push down firmly, grab it here and here, and push down firmly on either side, push down. A lot of times I'll pull the board out a little bit and then push it back down just to brush the contacts, and maybe there's a little piece of dirt or something in there, but I just pull them out about a 1/2 inch and push them back in. But you've got the IF audio board, you've got the reference board, this is the IF board, mixer, noise blanker, and then various other boards for displays in here. Let me see what my next slide is. Okay. Also, the VCO board, if you, for instance, if one band is not working, like for instance it's 10 and 15 meters, isn't working, a lot of times it's going to be this board right here. The other bands could be, and this is your VCO board, so if you're not locking on frequency, push this down, because this is where your lock and your references for that. How much time have I got, Evan?
3 minutes, Ron.
3 minutes? Okay. This is also a problem on if your VCO won't lock. There are 2 VCOs in the TR7. There's one that controls 20 meters down through 160, and then the second VCO controls 10 and 15 meters. The 10 and the VCOs run off the 24-volt power supply. If for some reason they won't lock, especially if it's on 10 and 15 meters, first place I want to check, make sure you got plus 24 volts. And this little transformer right here is usually the culprit, and this is the multivibrator, but this is usually the culprit right here. This is a 24 volt multivibrator, and this core, there's two halves of this core, is held together with this little twisted wire. What happens is, as you can see here, I took the twisted wire off, but it comes up a little bit. If you see those cores are not touching, you probably have about 20, 21 volts. And the VCO, the 32 megahertz VCO for 10 and 15 meters absolutely requires a full 24 volts or it will not lock. If you see, if 20 through 160 is working fine and 10 and 15 meters is dead, and your VCO is just kind of randomly running at 32 megahertz, the VCO is not locking, and this is the problem. What I recommend is you take a small, one little drop of super glue, super glue, and put it on each end, just one little drop, and stick it down in there and make those cores go together. It'll hold them forever. And I'm running out of time, I can see that. That'll hold them together, and but don't put glue in the second one, in the middle one, because that's where your continuity goes. All right, real quick, an L4B, if it stays keyed, everything seems to be working normal. A lot of times this little lamp socket it's a floating ground. If that touches chassis ground, that will keep your L4B keyed, even though the relay is in the receive position. Also, if you take an L4B apart, remember this little safety switch. I'll tell you what, when you spend $400 or $500 and have it refurbished, have the power supply built, and then you get it all back, you plug it in, and you put the tubes in, put everything in place, and you're going to fire it up. So, well, I'm going to test it before I put the case on it. If you don't have that switch depressed, you will blow the power supply, you blow the 82 ohm resistor, and it says if you're really lucky, that's the only thing it'll damage is to blow that resistor, but most of the times you're not that lucky. Okay, also, if your L4B, if you've got one tube that is drawing a lot more current, or it's a lot redder than the other, especially if it stays red or glows red when you're in the receive mode, this is the choke that goes bad. Drake runs grounded grid, but they use a choke from the grid position to ground, and a lot of times that coil will open up and your tube will even conduct. It'll grow cherry red in the receive mode. When you key the transmitter and you're pulling 1,000 watts or so out of it, that tube will go bright red. I mean, to the point where the plate can actually start to melt. It will arc over, and it'll short out and blow that coil. So make sure that coil is, because your tube is still probably good when it blew it. And it's usually developed from a plate to grid short. Let's see, what else? Okay, some quick rules for matching 6JB6s. Never mix different brands. The interelectrode capacitance can be different, which makes it neutralized. New and used tubes should never be mixed together. When matching, always use like manufacturers. Don't mix GE and RCA together, or Sylvania and RCA or GE. Make sure they're all the same. Make sure that they're all that each tube in idle is drawing roughly the same grid current, the same current for matching purposes. And I go in and I show you a little bit more about there. If you want to test a tube to make sure it's good, make sure you always test it for power output on 10 meters. Because 10 meters is the first band that's going to start to fail a little bit. The last slide, a lot of times when the caps come off, you unsolder this little thing here and stick it back in place. And I found that once this is soldered in place, it's still loose, held in together with a single wire. But I take a little super glue and I go around the entire edge after it's cool. And once that super glue dries, it gets under that cap, it pretty much bonds that cap to the glass tube, and it won't come off. So that's an easy way to repair it, because those, as they get old, the glue that was under their holes, it has a tendency to come off pretty quick. And let's see, that is all I've got. I'll be around after the forum for anybody who's got questions.
thanks, Ron. We really appreciate that. A lot of valuable insights there, and speaking from experience, those are things you want to pay attention to, but it's really nasty when you don't do things the right way. The next presentation will be by Rob Sherwood, and he's got a lot of useful information. It's always entertaining, and we look forward to having a good time with Rob here. Rob?
All right, well, you all got Drakes or you wouldn't be here, and you probably have some modern radios too. And it's interesting that the differences between them. There are trade-offs between different types of technology, and the digital does some nice things, and analog does other nice things. And we're all dealing with strong signals, and you can obviously copy the strong signals, but sometimes weak signals are an issue. And it isn't always just sensitivity. So there are subtle differences. You don't see them talked about in the magazines. And in fact, sometimes the magazine reviews kind of look like advertisements. And your Drake radios don't have some problems that you'll get from more modern equipment. So I'll go over that. Some of the older DSP radios, surprisingly, work better than the new ones in some respects. So everyone won't notice these, but some of us are sort of more finicky, and maybe once you point it out, you'll notice it anyway. One thing for sure, sometimes the manufacturer has a problem and they just miss it, and it's surprising to me that they don't compare radios, sometimes with a new one versus an old version of the same company. One thing that's been driving me nuts with most of the new equipment is the way the AGC functions, and also I had one radio that I purchased and it didn't like Q or Nancy at all. The static crashes just really went through it like there was no selectivity. So you need to listen to the radios and make decisions by your ears. And sometimes these mistakes make it through R&D and engineering and clear into production, and it's kind of surprising. So I was starting to evaluate some of the new radios. I think the first one was an Orion 1. And I was listening on 20 meters, and I was hearing a lot of clicks and ticks and pops, and at that point I was up at a weekend location belonging to my mother-in-law in northwest of Boulder. It's in the foothills, and it's generally a quiet location. But I was hearing these clicks, and I thought, well, I don't remember hearing those before, so I switched on my R4C, and I just didn't hear them. And I switched on my X-Line, and I didn't hear them. I thought, what in the world? Why is this a nice modern DSP radio doing this? So the case is these DSP units, if there's just a little transient, it thinks it's a signal that it should affect the AGC, even though it maybe lasts for a few tens of microseconds, and it's exaggerating things that is called clicks, ticks, and pops. It could be electric fence, it could be a light switch, it could be my rotor, like my tail twister when I turning the rotor and then I stop the solenoid across the switches, and that makes a pop. And it was really annoying to try to zero in the beam when heading, because I'd stopped turning and then suddenly the S meter goes up to S9. This is the first time I recorded something, and later on I'll have an A-B comparison, but let's see where I can find my little pointer here. Where is it? This is a recording I made several years ago, and listen.
Great opportunity to see God's handiwork in action. So thank you very much, Joe. I want to wish you the very best of luck. Have a wonderful weekend, and mobile safe out there. Over. Your signal into this part of the country is absolutely phenomenal.
So you see how the audio was just going all over the place, and that occurred in this modern radio, and the C-Line didn't do that. In the case of the ICOM, the last of the series, the Pro, the 756 Pro, 1, 2, 3, they were fine, and anything newer than that wasn't. The C-Line is pretty simple. It's got the AGC has got a resistor, it's got a capacitor, and then just a little spike isn't going to charge up that capacitor. But the digital processing, it just sees a spike and thinks that's an S9 signal when we just want to ignore it. So here's something I did a little bit later where I said, okay, I'm going to record a signal on one radio and another, and record it in the one on the left channel and the one on the right channel. And then, so we have the exact same signal going on simultaneously, and you can compare the two. Now, visually, if you just want to look at it, this is was the Omni 7, and I'm not picking on Ten-Tec because Yaesu, ICOM, you name it, most modern radios do this. You can see those spikes, that's my neighbor's electric fence. He's got some cows he's trying to keep out of my yard. And when the spike goes off, look at the audio, it just goes killed, and then it comes back up. The AGC discharges, and then the next pulse comes along and the audio gets killed. And that's what I was hearing. It's much worse on sideband though than CW because the bandwidth is wider, the rise time's faster, and so it's worse for sideband to me than on CW. So now here's going to be if I can keep my fingers in the right place, this will be the one that works right. This happens to be the icon. All right, now this is with the rig which any of these listed on the bottom would do the same thing. That drives me nuts. Now, the interesting, just before the Elecraft K3 came out, I wrote to Elecraft and I said, this is a problem with all these new rigs, and how about you guys figure out what's going on? And they were able to program their DSP to ignore it, and you can even turn that on and off in the Elecraft. So it can be fixed. Now here's interesting, we were talking earlier about somebody down here that said he could copy on 10 meters with his 2B better than he could with, I think it was an FTDX 5000. This a friend of mine I have a schedule with regularly, we're on 40 meters, and I was talking to the stateside guys, and he's up in Alaska, and he was listening on 5 different radios, a C-Line, a K3, and then a Yaesu and a couple icons, and for a period of time, he could copy Q3, not 100%, but Q3 on the C-Line just fine, and on the K3, but he couldn't hear anything on the other 3 radios. So it's not a sensitivity issue, it was 40 meters, noisy band of course, and it was just amazing. Now 15 minutes earlier, during this time period, he couldn't copy on any of those radios. For about 15 minutes he could copy enough to sort of realize that we were there on frequency and hear most of the conversation, and then 15 minutes later, all the radios copied just fine. And the signals are like S5 or something like that. So that was fascinating, and I don't know how to test for that in the lab. The other thing that I want to talk about is some of the radios don't like Hear Nancy. And I was hearing it, I won't have to speed through here, I was hearing it on a Icon 7000 in the car. Static wasn't bad, it was S9 occasional, and I was listening on CW, my wife was driving the car. And the static would go crash, and I'd hear audio that I swear that's several kilohertz of audio. So I said, I got to measure it somehow because my ears are telling me one thing, I want to measure it in the lab. So I use an FFT analyzer that it can take a snapshot of what's happening. So I wanted to test all 4 of these radios, your C-Line, my old Icon 781, and the 2 mobile rigs. And so this is a snapshot of these static crashes with these 4 radios. If you look on the C-Line and up here, you can see the passband was 500 hertz. The static could crash, and this is the time domain, this is the frequency domain, and any kind of noise from the static crash is gone by 2.5 kilohertz. This is 10 kilohertz, 5 kilohertz, 2.5. And the same on the 781. The static crash occurs, and they're just real clean out here. And then on my old 706, which is unfortunately what I sold to buy the 7000, it's real clean out here too. But look at the static crash here. Now, first off, you notice the skirts are really square and it's real flat top. But look at this audio. This crash goes clear out to 8 kilohertz when we had a static crash, and I'm listening through a 500 hertz filter. So that was just astounding to me. So there's weak points and strong points, but it's shocking that a radio that's 40 years old is coping better in a real environment with noise and clicks and pops and static and things like that. So go back and listen. Hopefully you've got an old radio and a new radio, since you've got a Drake, if I got an older one. And sometimes you just go back and forth between new stuff. You just have to pick whatever's working best. So are you ready to sell your Drake? Maybe you're not.
Thank you, Rob. We enjoyed that presentation. It's always informative to see as well as hear the phenomena that you're talking about there. Gentlemen, let's see. Let me mention some resources that are available for the Drake enthusiasts. We've got some nets online, the Sunday Technical Net. We've got the Tuesday Evening Net for buying and selling Drake gear, and then we've got the Drake Family Affair book. And all this information is going to be available online, so you don't have to copy it all down right now. Yes, sir.
Could you please make this presentation available online or on the Drake Net?
Yes, the presentation is going to be available. It's going to be videotaped. It'll be available online at the Vimeo website. That's Vimeo. It's there with the previous ones. And then contact me afterwards, after about a week or two, and if you want your name on the list for a CD, we can arrange that as well. Here's some optional knobs and heatsink caps for the Drake amplifiers made by Fred and I think Jim out there in the flea market. They also have some insulators for a ladder line and so forth. Alan Phillips, KC9YS, are you here today, Al? I don't think he was able to make it, but he's got some knob inserts for Drake equipment as well as Drake knobs. Radiolab Works has some LEDs for some of the vintage Drake gear for the 4-line as well as 7-line. And he's got these are he had the modules for the AUX 7 board. Just get by Sindri's website, LA60P, and if you go to DrakeMuseum.com, you'll see some more information about Drake. K3HRN has available a number of resources also. Bob, W78WK, has some extender boards to do any work on the TR7, TR7A. They're absolutely essential. Here's the AC Hamfest makes replacement capacitors for the AC core supply. W8CQ provides a number of products for the Drake enthusiast as well. Ham Gadgets has a interface board that I discussed in the previous forum regarding using the L7 or the L4B with the modern solid-state rigs. Here's some other resources. Again, these are going to be available online when you read these slides. And Mike March, he was here earlier. I think he might still be around. He makes some end panels for the 7-line there. Ron WD4HFN, go to his website. He's got a wealth of information there as well as some products for refurbishing Drake equipment. We mentioned the AC4 upgraded. Okay, John, we're just about out of time. Do we have any one or two real quick questions for the experts here? Yes, sir? Anything left of to my knowledge, there's not anything left of. They had an auction a few months ago and everything was sold off and bought and so forth, so I don't think there's anything remaining there, to my knowledge. Okay. We're going to clear the room then. Thank you all for attending, and we'll see you in the hallway for the distribution of the prizes. 73.